Welcome back to the Foundry by Forge College. Today, we're shifting gears in this explainer. We are trading the macro view of C-level performance signals, which we thoroughly mapped out in our last explainer, for the absolute precision of the drafting table as we dive deeper into hard hat fundamentals. If you've ever tried assembling a complex piece of furniture without the instruction manual, you know things can get wobbly really fast. Well, today, we are making sure our code doesn't wobble.
We're zooming all the way back in from the high-level observability of the network to upgrade our foundational tools right here on our local machines. Because let's be honest, building Web3 projects without type safety is a lot like sketching a suspension bridge freehand on a diner napkin. It might look kind of cool for a minute, but you definitely don't want to drive a truck over it. So we're here to reinforce our project before we even think about pouring any smart contract concrete.
Here is our master schematic for today's build. We'll quickly cover why TypeScript is our best friend here, how to install our engineering tools, configuring the compiler, translating our old configs, validating that everything is structurally sound, and finally, a quick safety checklist for common pitfalls.
Let's jump right into Section 1. Why use TypeScript here? It's all about reinforcing that scaffolding.
You can really see the visual difference between how we write code here. On the left, standard JavaScript gives you the freedom to move incredibly fast, just like those loose orange ink lines. But as your project grows and gets more complex, that freedom can turn into a tangled mess. TypeScript on the right acts like a very strict geometric site inspector. It ensures every single module aligns perfectly before you run a single line of code, meaning you won't face a catastrophic tear-your-hair-out refactor 6 months into your project.
Section 2. Installing our tools. Let's open up the Engineering Toolkit.
Okay, so bringing these tools into our workspace is a straightforward 3-step drafting process. Step 1, we grab the core compiler, that's TypeScript and TS node. Step 2, we add the types for our specific Node and Mocha testing environments. Think of this as basically handing our compiler a dictionary, so it actually understands what Node is. And step 3, we equip TypeChain plugins to handle the Ethereum-specific elements, so our smart contracts will eventually be just as strongly typed as our configuration.
Section 3. Configuring the compiler. Time to draw up the master blueprint. Looking at this technical specification sheet, we have a few absolutely crucial compiler settings in our tsconfig file. We're specifically targeting ES2020 to keep our async/await functions intact for modern Node runtimes. We use CommonJS for our modules to perfectly match the vast majority of NPM packages out there. And you definitely want source map set to true, because when something breaks, and trust me, it will break eventually, we want the error trace pointing exactly to our shiny new TypeScript code, not some unreadable compiled output.
Now, if you memorize only one thing from this blueprint, remember esModuleInterop. I know it sounds a bit complicated, but it's simply the critical adapter that seamlessly bridges the gap between CommonJS and ES modules. Without it, your compiler is going to throw a tantrum every single time you try to import a standard package. Turn it on, and everything just plays nice.
Moving on to Section 4, translating configs. Let's actually draft these schematics. We start by renaming our trusty hardhat.config.js to a .ts file. Then we use this specific esModule import pattern. By pulling in hardhat user config, we are suddenly given strictly typed access to all of hardhat's configuration helpers. Honestly, it's amazing. Suddenly, your code editor will start auto-completing options for you, which feels exactly like having a tiny little engineer sitting right on your shoulder guiding your keystrokes.
Then, inside our actual script files, we'll import the HRE, the hardhat runtime environment. Think of the HRE as the core mechanical engine powering your entire build. Importing it in TypeScript gives you incredibly robust typed access to helpers, like your compiled artifacts and your network details.
Section 5, validating builds. Let's perform the site inspection.
Let's put on our hard hats, pun absolutely intended. To make our lives a whole lot easier, we'll add these 2 utility scripts directly to our package manifest. The build command simply calls the TypeScript compiler to inspect our work. The typecheck command uses TS node to run hardhat directly in memory with typechecking active. This means we can easily command our system to verify everything with just a couple of quick keystrokes.
Running that npm run build command is our official site inspection. What we are looking for is a completely clean compilation with 0 error messages, an exit code of 0, and the magical appearance of a dist directory. If you see this, take a bow. Your scaffolding is completely pristine.
Section 6. Common pitfalls. Let's run through the safety checklist.
Now, if the compiler starts yelling at you, don't panic. Just run through these common fixes. Number 1, ensure your config file is exactly named hardhat.config.ts. A rogue.js extension will absolutely ruin your day. Number 2, make sure you aren't missing crucial node type packages. And if you get module errors, double-check that your tsconfig is set to resolve CommonJS properly, just like we mapped out a few minutes ago.
And here is a pro tip from our other development modules in the learning programs here at Forge College. If you are really stuck, try running your scripts with the environment variable debug set to an asterisk. This acts like a giant magnifying glass, giving you incredibly verbose logging that will easily illuminate any hidden plugin or loading issues deep within the engine. It's a real game changer. Finally, our conclusion and key takeaways. Let's finalize this blueprint. To maintain perfect structural integrity in your projects moving forward, just remember these 3 rules. First, always align your compiler configuration directly to your Node and Hardhat runtimes. Second, always utilize typed imports so your code editor can actually help you out. And third, and this is a big one, convert your existing scripts incrementally. Do it one file at a time to avoid a massive, discouraging cascade of confusing errors.
So, I leave you with this question. Now that your TypeScript scaffolding is rock solid, your tools are fully upgraded, and your environment is strictly typed, are your blueprints truly ready for the complexities of authoring your very first smart contracts?
I certainly think they are. Head over to forge.college to explore more Web3 concepts, dive deeper into our curriculum, and join us in the next explainer as we finalize this setup and compile our very first Solidity contracts using this brand new bulletproof TypeScript armor. Until then, keep building smart.